So again, I just thought while I'm here at the Angel, I just thought it's opportune just to talk through how the connections are made. I know I've touched on it previously, but you can see here in the video we've obviously got our heavy duty metal male plug and pin assembly here with the grey YY 7-core cable coming from it. And just to zoom in a cross section, you can see there we've got 7 cores. Basically Sicotronic uses 4 cores and a earth to make its connection, and basically one of the cores is labelled A, the other core is B, another core is C, another core is D, and the final one is earth, of course. We use 7 core, so we've got a couple of spurs, and in essence A is the core that tells the computer that power has been turned on to the appliance. B is the core that tells the computer that the operator has now turned the thermostat on. C, it bridges to C to tell that we need to put power to the elements, and then say D is the neutral. I'm just losing focus there, aren't I? But D is the neutral that obviously configures the power. And these cables will either run 230 volt off the catering equipment power board, so the PCB in the unit, or it might run 24 volts. And we use those voltages to act as a signal to the computer. Once that goes back to the computer, just dump that down for the time being, the computer basically has the brains in it that tells the appliances to switch on and on. So effectively the brains here is a PCB computer. In there is some clever programming software that's been developed over the last 35 years back in Germany, and effectively the intelligence in that program decides when power is available, when pieces of equipment are calling for power. It will then search all this knowledge in there, it will search through it to see what appliances don't need power. It will in milliseconds turn the power off, and it will constantly pulse power back and forth from different circuits, sending it to the equipment that's calling for it. So you're constantly getting an even pattern of power distribution around your kitchen. So when people say, what does Sicotronic do? The simplest way, I've said it before, for me even, I'm not technical as in a Sparky, but I've been in kitchens a few years, but for me the easiest way to understand it is it's an intelligence switch, and it's basically using the boards on the equipment itself to determine how much power we've got and how long we can borrow power from one appliance and send it to another and then send it back. The intelligence is really good, that it will never take the power for too long to the detriment of cooking. So it's that intelligence, it will manage the cooking process, so a chef won't really see any difference. And I think in the previous video when I was at Liverpool with the Eco Chef, I think particularly I might have shown you inside the controller in here, for example, the plancher, but in the appliances sometimes the manufacturers put in an A, B, C, D port, which you saw us in the last video connect to, which is great. Or like Fluxron, it's built into their generators. Other manufacturers who are not yet optimising or are not fully aware of the standard, like Mayday for example, they very kindly allowed us to determine where we put the switch in. So what we do is we send the wiring diagram to Germany, and the electronic engineers in Germany, it's Sicotronic head office, they'll take the wiring diagram for this appliance, read the wiring diagram, and they will look into the system to see how we make the interface. And then what we do here in the UK is we actually just literally bridge into the circuitry. So we create the switch in the circuitry, based on the electrician's job. So it's not magic as such, but yeah, it's just some alteration. Most pieces we can alter in the UK. We can obviously optimise most pieces via our colleagues in Germany doing the interface for us. As we found out this week, some appliances you can't interface. That's predominantly because maybe they've got too great a power in their power circuits. I think we had an instance this week where we had 400 volts in the circuitry, so it's just too great for our system to manage. Our system works on, Sicotronic works on 12 volts, 24 volts and 230 volts as switches. And the other thing we've learnt in the UK, well that's blocked up now unfortunately, but the other trick that we've learned is that the relays have to be ordered specifically to the circuitry. So it's very important early on that we get the specifications and model numbers of equipment, and then we can source the right EAM modules, components inside to make the switch. Otherwise we'll end up blowing things up, of course. So yeah, hopefully that helps as a little bit of feedback on Sicotronic. Thanks for listening.